So let's look at BB84 again and ignore the places where the differences, places where the bases disagree. Because we're throwing those out anyway, so we can just concentrate on the places where the bases agree. Alice sends Bob random bits. Let's call these B. And Bob gets B plus E. This is over the quantum. Alice sends Bob. What was it? B plus C, where C is in some classical error correcting code. Let's call it C in C2. Let's call that classical error correcting code C2. Bob takes B plus E and B plus C and adds them. You get E plus C and corrects it to C. So back over here, Alice sends Bob X plus K plus C on a quantum channel. Sends Bob T on a classical channel. And Bob gets X plus C plus T, adds T gets, no, he gets X plus C plus E plus T plus E, adds T, gets X plus C plus E in C2. So here he got, okay, I just noticed that I have done nasty things with variable names, which is so very common. So let's call this C tilde. And C tilde was in C2. And so we have a, I mean, just looking at this, we can have a dictionary. T here corresponds to B here. T corresponds to B. So Alice sends Bob something in C2 plus T on a quantum channel. She sends him T on a classical channel. And he adds them and gets something where he can decode with the code C2 to get the error. So, and the same thing is here. Alice sends Bob B on the classical channel, B plus C, B plus C tilde on the classical channel. So I guess B plus C tilde corresponds to T, and the thing she sent on the quantum channel was X plus C plus T. So this is this is BB84, and this is modified Eckert. So X plus C plus T here is what she sent on the quantum channel. What did Bob send on the, Alice sent Bob B on the quantum channel. And in both cases, Bob gets In both cases, Bob gets the quantum channel with an error, adds it to the classical channel, and decodes using the classical code C2. Here, Bob gets that. He adds this, and he decodes using the classical code C2. So now they have, so now they agree on B in C and X plus C in, or rather, they agree on C tilde in C and 2 and X plus C in C2. But the code word, the secret key, is actually just X. Secret key here, key, is X, which is the coset of C1 in C2. So what does that correspond over here? Well, remember I said that Broussard and Bennett, you said you had to hash this thing to get rid of any information that Eve might have gotten out of it. So you hash this by taking coset of C1 in C2. So instead of using this entire code word in C2 as a secret key, you just find the coset of C1 and C2 this corresponds to and use that as a secret key. And that is a hashing in BB84 protocol. So this shows exactly how the BB84 protocol corresponds to this protocol where Alice takes half of a whole bunch of EPR pairs and sends them to Bob over a quantum channel and makes sure that the channel is makes sure that the channel is secure by testing the actual error rate of the phase error rate and the bit error rate of the channel and making sure that the quantum error correcting code can handle that. And that, of course, is the same thing that Alice and Bob did in the classical in BB84 by finding the error rate by comparing, a sample of these qubits. And if the error rate is too high, they abort the protocol. So BB84 is completely, well, one flavor of BB84 corresponds to this quantum error correcting code. You can actually use a whole bunch of other hash functions. And one of the, here we're using the hash function corresponding to a code C1 that is contained in C2. One of the proofs of security of BB84, which was long and complicated, shows you can use any error correcting code whether or not it's contained in C2. But that's for the hash.